So what I'd like to start out with today is going through the list of frequently made mistakes from assignment 1A. At this point, everybody should have your comments back on assignment 1A. If you don't have comments back on assignment 1A, let me know as soon as you can, because something has gone wrong. So first comment, kind of a meta comment, make sure that before you turn in your final version of the code that you comment your code. A lot of people didn't have any comments in the code. You'll get points off if you don't comment it. So make sure you explain what it's doing. In some cases, it's pretty easy to tell what's going on. In other cases, it's not so obvious. So make sure you comment the code. All right, so let's take a look at some things. First of all, you can remove mend and anything that references it. In the next skeletons, the skeletons for assignment 1B, I got rid of mend, so it's not there anymore. Another thing to note, you don't have to actually put an initializer for things like, oops, I guess this should actually be private int msize. You don't have to put an initializer for that because those things default to 0, so you don't have to do it. Likewise, in the array constructor, you don't have to assign msize equal to 0. It's already been initialized to that by default. It's not wrong to do it that way, it's just redundant. Subtlety here, don't set msize equal to initial capacity. It should just start out at 0. And then as you add things to the array, it'll increment the count, the msize count by 1. So don't start out with having it set to initial capacity, otherwise it won't work right. Another thing you don't need to do, you don't need to be checking whether melement data is null or not. If it's null at this point, then something really horrible has gone on. And so it means your constructor failed for some strange reason, which should never happen. So you don't have to check to see if melement equals null. A lot of people had the wrong check to see whether or not the collection was null. It's not that the collection is empty, it's that the collection is null. The reference itself is a null reference. So don't check if it's empty, you have to check if it's null. Also, you should be able to do this code to avoid an explicit loop. Well, let me rephrase that. There's a couple different ways to implement this thing. One way is to use a loop like this. Another way is to use your existing methods, like the add method. That's probably a good one to use. For this comment probably should say something more like, please rework your solution to avoid indexing into the code the way I'm doing it here. This will have other problems too, because if you don't properly regrow the array as you're adding stuff to it, you could end up with a null pointer exception there as well. So the basic point here is to reuse existing other methods, such as add. All right. Oops. This is a really minor point, just good to get in the habit. Don't write code that says, if msize equals 0, return true, else return false. Just say return msize equals 0. So that's just the way that a Java program would implement this. This one is particularly twisted. So the solution here is trying to use binary search to find the index where the item occurred. Well, there's one giant problem here, and the giant problem is that binary search only works if the array is sorted. But we don't know what the order is of these elements. We have no idea. By the way, no laptops in class, please. So in this case, that's just not going to work, right? Because we don't know whether it's sorted or not. So that'll do something very strange. A number of people did a really good job of trying to use Java 8 code to do the index of operation. Very clever, very good. I'll explain how this works in a second. There's just one problem here, which is this code will fail if object O, the parameter, equals null or is null. And the reason for that is that if you try to, if this element here is a null, then melement data sub I will return null. And you can't say null dot equals. You can only call methods on a non-null reference. Otherwise, you'll get a null pointer exception. So you'll have to do a little bit of extra. If you want to do this kind of code, which is fine, by the way, you'll have to do a couple of extra checks to make sure you're not going to blow things up. What this is doing is this is going through a range from 0 to less than msize, and it's filtering out all the elements where it let's see, where they equal each other, and then it finds the first one, and it returns that index. And so you're trying to find the first place where the element in the array equals the parameter that's passed in. And then you find the first one, and if you don't find anything, you return a -1. So it's very clever use of Java 8 functional programming and streams and so on. Good job, all those of you who did that. Just make sure that you are careful not to blow up if the value equals null. And that's why you have to do a separate check. I'll talk more about that in a second. Once again, you shouldn't need to check to see whether something is null. That should never occur. You could do it is empty if you want to, although that's kind of redundant based on how this code works. So here again, a lot of people got this wrong. This code will fail if object equals null. So if object equals null, you're going to be trying to say null.equals, which will blow up. So you have to do separate checks. And this particular piece of code also had another problem, that it never incremented index. So it would always return 0, no matter what it found. It would always return 0. Another thing, it's not incorrect to have object O be null. That's a perfectly valid thing to check for. There's nothing wrong with searching for a null element in the array. So don't just bail out immediately if it's null. And then down here, this is another mistake that a number of people made. You can't say if m element data sub I equals 0. That'll just check to see whether that element is, equal O. That'll check to see if they have the same reference value, not whether they're equal. And of course, you're unlikely to ever find that being equal, because it's unlikely that the element here would have the same reference value. It might be the case, depending on what O was, but chances are this is not going to work the way you want it to work. All right, so you need to use equal, not equal. You have to use the equal method, not the equal operator. Now, some other people did this check. They checked to see whether something was null inside the loop. And the reason you don't want to do that is you don't want to have to check each time. You just want to check once. So this is less efficient than it could be. So the best way to do this is to split it into 2 different loops, one of which handles the null case, one of which handles the non-null case. So that'll help speed things up a little bit there. Add all. Probably don't need to make a new array. There's other ways to do this that's more efficient than making a new array here, or more concise. This is way too complicated. There's a bunch of different ways to implement add all, but you probably don't want to have to make 4 copies of stuff in order to do this. It's way overkill. There's much cleaner ways to do it. I couldn't even really tell if this code was correct. It just had so much going on, but it looked like it was inefficient no matter what, just because of all the copies that are happening. Try to get in the habit of using a for each loop. If you need to use a loop at all, and there's a couple cases where they're probably a good thing to do, try to use a for each loop, not the iterator, just because the iterator is more verbose. It's probably going to work the same in terms of performance, but it's just a little bit more complexity that you don't really need. So get in the habit of using a for each loop in situations like this. Down here, definitely try to avoid as much as possible, not always possible, but as much as possible, try to avoid using index-based for loops. This is an index-based for loop because you go from I equals 0, and then you use I as an index. And that becomes a problem because it's all too easy to get, is it I less than a.length? Is it I less than or equal to array.length? It's easy to get that wrong. It's easy to forget to increment. So just get in the habit of not using these unless you really, really, really need to. If there's no other choice, maybe index of might be an example. There are other choices, but that could be one place where you could use this kind of loop. And also, you don't really need to do the to array because that's going to go ahead and make an extra copy that you don't need here. So you can just simply access, you can just use the operation here to get the element that you need here. There's a bunch of different ways to do this. If you use a for each loop, it'll make it clean. Once again, don't make something an array and then use as list. This is just too much extra conversions going on for no particular benefit. So try to be clean. My solution uses a for each loop and the add method, which is nice and concise. May not be the most optimal, but it's pretty concise. You don't need to check to see whether or not all the elements of the array equal the elements that you're adding. I'm not even sure what this is trying to do. I mean, it's kind of like, this is definitely wrong. This is saying, if everything in the array we're trying to add to the existing array is already there, don't add it. Well, that's not really the case. Add all is just like an append, right? It's putting things at the end. So you always want to stick the stuff at the end. This is really inefficient. Do not make a linked list. I don't even know what this is trying to do, but it's very confused. It's not the right thing to do. You know, don't eliminate nulls from the array. It's perfectly fine to have nulls in the array. That's not a problem. And also try to avoid using get, because get is going to check the range each time. We don't have to do that because we know it's going to fit. So you shouldn't worry about making that check. Same thing here. Don't use get. There's better ways to do this. I guess another thing here is don't use a for-based index loop. Use a for each loop instead. A surprising number of people got range check incorrect. You always have to remember the classic fence post problem with Java and C based arrays is if you have an array of size m, if you try to access the mth element, it's going to go out of bounds. So you have to make sure that the index is less than or equal to m size. Or rather, you have to make sure that the index is going to be less than m size if it's, let's see, is this right? Yeah, this is just totally messed up. So there was other people who did something similar where they should have said less than or equal to, and they said, they should have said less than, they did less than or equal to. So look carefully at range check. I think I've found most people who got it wrong and flagged it for you, but you have to think carefully about what range check is trying to do. I think this is actually, got the whole thing reversed. So also make sure you run the test program. A lot of these errors would trivially be caught if you ran the test program. So make sure you run the test program. This will be especially important as we get the more sophisticated testing programs in the later versions of this assignment and subsequent assignments. So that'll catch a lot of these errors. Also, this is wildly expensive. Do not use exception handling to do simple range checking. That is going to be, it'll probably get caught. It should get caught if you try to index into something that's out of bounds. But using exception handling is wildly, wildly inefficient. Just do a check. Do the right check like this, but don't write code like that. It's not the right way to do it. Here's another case. This is a very common case. Someone checked if index greater than the length of the array. Well, it should be greater than or equal to. Because if it's equal to, it's also going to be out of bounds. So that's the classic fence post error with Java and C based arrays. A lot of people had problems with remove. First of all, get in the habit of using the range check method. That's why it's there. So if you write range check, use it. Use it for remove. Use it for get. Use it for set. I think those are the three to use it for. There might be one more. So make sure you use the range check method. Don't use get. Try to avoid using get internally because that has this range check that you don't need. You already checked the range. So if it got past this check, then you know it's in range, so you don't have to check again. And avoid, this is a good example of where you can not use a loop. So don't use a loop. Instead, use the array copy, the system.array copy method, which will do some optimized movement of data a little bit faster than using a loop and less error prone. A lot of people forgot to call range check, so that's what's missing. Definitely don't be allocating a new array when you're going to remove something. That's hugely inefficient. And for some reason, there's lots of stray array copies going on here. I'm not sure what they're trying to do, but you only need to have one. Make sure that you check the range before you access the element in get. Same thing in set. You have to do this. You have to make sure you check the range. Some people forgot to return values. That, again, should be something that your compiler should flag for you. You don't need to make a copy of the data when you're doing a set. I'm not sure what that's all about, but that's wildly inefficient. You're just changing one element. If somebody tries to call set and the index is out of bounds, you should get an exception. You shouldn't grow the array. That's just the semantics of how set works in Java. I wasn't sure why temp was being checked and add was being called, but that's unnecessary. It should be a lot simpler than that. Add, I'm not sure what was going on here, but you don't want to make a copy of the array. You just want to add an element at the end of it, so it should be efficient. Of course, you have to make sure you have enough capacity first, and make sure you call the ensure capacity internal method to increase the size of the array. We'll talk about that in a second. Some people forgot to do that. Some people forgot to call ensure capacity internal here. So make sure you do that before you start trying to add things to the end of the array. Otherwise, it'll blow up. A lot of people did the following. They simply took whatever min capacity was and just made a copy. They made a new array that made it as big as min capacity. And the problem is the most common use case for ensure capacity internal is calling add, where you're just adding 1 to it each time. Well, if you do that, then every time you call add, it's going to have to reallocate the array, which gets very expensive. So a much better way to do this is to grow the array bigger than you actually need it, so that you'll be able to amortize subsequent calls to ensure capacity internal. And there's a bunch of different ways to do this. One popular way is to double the array each time, and that way if you do n adds, you'll only do log n, or O of log n resizes, so it's much lower. You could also add in a fixed amount. You could take the capacity and divide it by 2. Whatever you do is fine, but just don't blindly use min capacity, whatever is passed in, because chances are that'll induce the most suboptimal behavior where you have to recopy the array every time you add one element to the end, which is wildly inexpensive. So try not to do that. For the iterators, get in the habit of not creating local variables pointlessly. Just return the array iterator. Some people forgot to put stuff here. They forgot to put fields, so their code was incorrect. This code is too complicated. Next should be very simple. It should just use the array get method, and that'll check for all the various exceptions and so on and clean things up quite a bit. I mean, there's a few other things you may need to do, but that's the gist of it. And the remove method on the iterator is also way too complicated. Just call the remove element on the array to do the work. And then remember that there's a few other things you got to do in addition to calling remove. You have to update the last pointer where you did the work so that you can have the semantics work properly. OK, so that's a summary of the frequently made mistakes. Hopefully, this will help you in your revisions that are due next week.